And then, if anybody in your group, if you want to raise your hand and say, hey, let's take a break, that's great. Very informal. I love to have questions as we go through. I'd prefer that over you holding a question, and just speak up if you have a question or a comment, or you tell me, no, that's not the way we do it here, and then we can certainly chat about it. So I've been in the pavement preservation business since, well, really about been in the asphalt business since about 1978. Started microsurfacing in 1992, but was doing chip seal, crack treatments, and a few other preservation things before that. That was before we really even knew the term pavement preservation. Since then, I've been a contractor for 22 years, and then I sold pavement preservation equipment for about 8 years, and now I work for the National Center. I also do some other jobs in the industry. I work for a Phoenix-based preservation contractor part-time. I also I'm executive director of the Pennsylvania Asphalt Applicator Association, which is basically their pavement preservation group. So been around a long time. With me today, and I'm going to start with Todd Shields and let Todd introduce himself, and then I can't see who else from the PG3 team is here. So.
All right, very good. Well, I'll just pass it off then. So good morning, everybody. Thanks for joining us here. Todd Shields with the National Center for Pavement Preservation. I've been here about 4 years. Prior to that, I was with the Indiana Department of Transportation for 28 years. Various roles in asset management and pavement preservation, but a lot of interest in chip seals, so that's good. You guys are doing a variation on a chip seal. So let's see, I see Bouzid and Eddie, so maybe let Bouzid go next.
Yeah, Bouzid Shuban. I'm with the National Center for Pavement Preservation at Michigan State University. And before that, I was with Florida DOT for some time. Glad to have you here. Like Greg said, please ask questions so that we have a productive training. Thank you.
Eddie, you want to introduce yourself?
Hi, everybody. This is Ed Johnson. I'm an asphalt researcher out of Minnesota DOT Office of Materials and Road Research, and I guess I'm going to be involved a bit in the back end of collecting and organizing some of the data that states like yourself are going to be adding to the project. Thanks.
Thanks, Eddie. Do you know if Joel's going to be joining us, Eddie? I guess we'll see if he jumps on. He's not on currently.
Right, thanks.
Yeah, Joel is the, he's Minnesota DOT, and they're the lead, as you're going to learn here in a second. So we'll see if Joel makes an appearance. Rick, there we go. You want me to keep going, or it looks like this is my part anyway, unless Joel's on. Rex, you're muted. Oh, no, you're not. Did we lose you, Rex?
No, here we are. I'm sorry.
Okay.
Yeah, go ahead, and I'll let you take over from here for this next couple of slides.
Yeah, Eddie and Bouzid, if you want to jump in and add anything, that's fine. So go ahead and move on. So just wanted to explain a little bit here, background for most of you guys, I'm guessing may not fully understand what this project is. PG3 is kind of a colloquial term. The title is actually there. You can read it. The National Partnership to Improve the Quality of Pavement Preservation, Treatment, Construction, and Data Collection Practices, which is quite a mouthful. So this is a pooled fund. And if you're not familiar, pooled funds are mechanisms for states such as Washington to jump in, partner with other states, and pool your funds, as it says, and accomplish a bigger project than what you'd be able to do on your own. So that PG3 is a pooled fund, and there's some websites here. You've got the actual solicitation and then the PG3 website. So go ahead. So what makes PG3 different? So this is actually, PG is preservation group, and the 3 is we're in phase 3 and out of that. So phases 1 and 2, and I guess start with phase 1, was an Alabama DOT project. It was the NCAT test track there at Auburn. And then I think they had a road, the DOT had a road that they had, but it was test sections. And then phase 2 was where Minnesota got involved with the Min Road facility. And again, it was test sections on the tracks and then a few roads that they did projects on, but it was purely in Minnesota and Alabama. So the phase 3 here is focused on the implementation aspects. So states get involved and they're actually able to construct their own projects. So what we provide.
Todd, correction, it's not Alabama project. It's also pool fund. There were other states involved, including FP2 and the partnership. So just so that I don't think it's just Alabama, correct? It's still pool fund.
I'm not sure where you're even seeing that, Bouzid.
Phase 1, PG1.
Yeah.
Yeah.
It was a pooled fund.
Yeah. Okay.
All right. So yeah, as Bouzid said, so this is a partnership, and I'll show a map here in a second of all the states that are participating. But Minnesota DOT is the lead. The National Center is involved as one of the technical contractors. NCAT's involved, and then we've got Federal Highway and FP2, which is the Foundation for Pavement Preservation. So yeah, there you go. We had 20 participating states. It's great participation in this. We've got all across the country. We've got all of the climate regions covered. So it's great participation. I think the last state we had to join was Arkansas there. So 20 states, and that's probably where we're going to stay for the next couple of years. Okay. So the project support, and we don't need to go into great detail on this flow chart, but what we do, we'll either help you develop specifications, we'll review your existing ones. We provide training exactly like we're doing here right now to hopefully the DOT and the contractor staff. And then the goal is we'll have someone on site helping when you construct your test cell on State Road 14. So, and then as Eddie said, we will help you collect data and then monitor the performance of your project. So go ahead. So what we do, last year, we kind of got into the swing of things. North Dakota, they joined the pooled fund. They had built a bunch of test sections prior to PG3 even starting. So they're just looking for help, training, and then data collection on those test sections that they already built. Mississippi, last April-ish, I think, constructed their scrub Cape Seal. That was the first for them. Idaho did their first 100% wrap chip seal, which is something that's really catching on nationwide. And then Minnesota did another scrub Cape Seal way up north. North Carolina did a spray applied rejuvenator, and that was part of the PG project, and they're starting to take off and do a lot of that now. And then Delaware is trying to get back into microsurfacing, and they've got an interesting situation where they had a road with a lot of Amish buggy traffic. And so they're using the microsurface to fill in the ruts that are caused by the hooves on the horseshoes. And then coming up in 2026, Alabama's already done their scrub Cape Seal. That was a first for them. That was done April, May. Alaska just in the last couple weeks did a chip seal in the Juneau area. And if you guys are familiar with the Juneau area, there are no roads in and out of there. And it's a rainforest. So that was an interesting one. They had to actually bring equipment in. They had some issues, but they got it done. And then we think next up will be you guys with your rut fill chip seal. And this may be a good time to ask, do we have a better idea now on construction for State Road 14 dates? This is the interactive part.
Yeah, this is probably me since Andreas isn't on here. It sounded like we're supposed to kind of start work the week of July 20th. But I haven't really seen a schedule when they'll actually start shipping. So
you said there'll be some pre-work, right? There's patching and some crack seal ahead of the chip seal.
Correct. Yep.
Okay, very good. And then for sure this year we'll have New Mexico. They are also going whole hog into wrap chip seals. They're looking at September for that one. And then Michigan DOT has been poking around with less expensive versions of high friction surface treatments. And so they're they're calling it enhanced friction microsurfacing, not to confuse it with it, but they're blending in the calcined bauxite with their native aggregates and seeing how that performs. So they're looking to do that in September as well. So there's a website, I mentioned that earlier, the PG3 study website. If you want to visit that, we post all of the trainings that we do. Like this one will be posted out there, so you can go back and look at other states that we've done training for, information about the fund, upcoming meetings, and then other resources. There's some forms I think Rex is going to get into here in a little bit that that are out there on the website. And I think, is that it?
Some upcoming activities.
Upcoming activities with it. We got our training with you guys today. There will be, and I don't think Karen is gonna, yeah, Karen's in Japan, right? So she's not able to make today, but we do have another virtual TAP. That's the technical advisory panel coming up middle of August. That'll be about an hour or so virtual. So we do have 2 in-person TAP meetings every year. We did back in May in conjunction with the Northeast Pavement Preservation Partnership. We'd met, and then the next one in person will be not in conjunction with a partnership meeting, but it'll be a kind of a standalone, but we'll get to visit and tour the Min Road test track. And then following up, there'll be another virtual TAP over the winter, and then we will have the first in-person meeting of 2027 will be May at the NCAT facility. So they do a 3-year cycle, I believe, on their test track, and so this will be starting a new cycle with the test track. So we'll be part of that. And I think that's it now.
Yep, I think so.
All right. Anybody got questions or anything on the pooled fund or what this project is and what we're trying to do? Okay, we'll put stuff in the chat. I'll try to keep my eye on that and appreciate everybody. Go ahead, Rex.
All right, very good. So first of all, I want to let you know who National Center for Pavement Preservation is. We were established by Michigan State University and the Foundation for Pavement Preservation back in 2003. And basically we lead collaborative efforts among government, industry, and academia in the advancement of pavement preservation. And we do that by trying to improve pavement preservation practices through education, research, and outreach. So we collaborate with AASHTO. We work with their preservation management partnerships, the old TSP2, if you remember that, still going, just with a new name. We work with the Emulsion Task Force, the ETF, which is a great group of folks. And the Emulsion Task Force started several years ago. And its role was, its main focus at the time, and we're still working on it, is to how do we develop emulsion specifications that kind of mirror the asphalt cement specifications that we have now with the temperature gratings and those sorts of things. That's been a little more difficult than we thought it would be, but that's still part of what we're working on. But the Emulsion Task Force is kind of turned into all things pavement preservation, recycling as well. So they're very good meetings. Membership is open, and if anyone in the Washington DOT is interested in joining that, I would get with Todd and we'll get you lined out. We also collaborate like through this with Min Road, NCAT, with PPRA, the industry groups for pavement preservation, to advance the pavement preservation. To advance the practice, we have every 4-year National Pavement Preservation Conference, which will be in the fall of 2027, I believe in September, in Grand Rapids, Michigan. We do research projects like this and others, and we've done training and education surveys to help industry understand how state DOT and local agencies want to obtain the training that we give, what's important for them. And then we try and improve pavement preservation. We have a pavement preservation certification program. So we certify contractor employees, certify contractors, we certify state DOT employees, and we could even certify a state DOT if they do self-perform pavement preservation like chip seal or things like that. So we have close to 1,000 employees across the United States certified in either crack treatments, chip seals, or microsurfacing. Some have all three. And we have some individual companies who are certified, not as many as we'd like. We've got 2 that are certified in microsurfacing and 3 that are certified in crack treatments. Right now, I don't think we have anybody chip seal certified as a company, but we're working on that. So, and then we try and again improve our agency and industry training. We do a lot of that around the country. So I want to get into pavement preservation and so the first part of this is we're going to be talking about what pavement preservation is, why we should be doing it, how it benefits your department, how it benefits the taxpayers, and then how chip seal, which you all have selected as your project, fits into pavement preservation. We'll also talk a little bit about emulsions because that's part of many of these treatments, including your chip seal treatment is an emulsion-based treatment. So we're going to get into that. I'd like to start with a definition of pavement preservation. This is an older federal highway definition. Programs and activities employing a network level, long-term strategy that enhances pavement performance by using an integrated, cost-effective set of practices that extend pavement life, improve safety, and improve motorist satisfaction while saving public tax dollars. In order to be considered pavement preservation, the treatment must address pavements while they're still in good condition. It must reduce aging. It must extend pavement life, and it should restore serviceability. I have a problem with that. That's why it's asterisked, is just because if we're getting on it while it's still in good condition, we really shouldn't be needing to restore serviceability. And you know, I'm going to tell you this a few times, the road that you've chosen here is a little bit beyond good condition. And so we're kind of out of this preservation cycle. We're into preservation maintenance, and that's fine. But I think our goal as association, and our goal is this, or you know, for the National Center, and our goal for this PG3 study is to help DOTs like you move closer into a true preservation mode when your budgets and other political things allow. So let's define that definition. It's very important, if you're going to have a pavement preservation mindset, that you include all your pavements, and that's urban, that's rural, that's your airports. If your state manages airports, that's parking areas, that's state parks, that's every pavement that's under your jurisdiction should be in your network, and your pavement preservation should be looking at those. You need to look at your asphalt and concrete. For so long, we've thought, well, concrete doesn't need preservation. Well, it does. And there are things that we can do to your concrete pavements to help them last longer as well and keep them in good condition. It needs to be a long-term strategy, a budgeted expense. The best states who really excel at pavement preservation budget for it. And they don't take money out of their pavement maintenance, pavement preservation fund when they have a hurricane or a downturn in the economy, or whatever issue. They continue to fund that pavement preservation because they understand that keeping those good roads in good condition saves them money in the future. And it needs to be integrated. It needs to be department wide, all stakeholders. And so I guess what I mean by that is if your maintenance department has a pavement preservation strategy, but your pavement engineer group or other parts of the DOT don't, you're working against each other. And so the entire department needs to buy into pavement preservation. And again, cost effective, right treatment, right road, right time. One way to bring this home is we've been working quite a bit with the Mississippi DOT and did some training, actually almost a month of training in Mississippi this spring. And one of the things they told us, the reason they decided they better get into pavement preservation is they did a study over the last 5 to 10 years. Their, and I'm using air quotes here, their pavement preservation process of choice is a 2-inch mill and fill, which is really almost outside what we really think of as a pavement preservation tool, but that's what they had. In fact, when we asked them what they used, they said, well, we have 2 tools. We have a hammer and a bigger hammer, and they were both mill and fill, just depending on the depth. But they determined that when they did a mill and fill, a 2-inch mill and fill, 50% of the time they chose incorrectly. 50% of the time it was not the right treatment on the right road at the right time. And so about 2/3 of that, the time of those times when they were wrong, it was too much. They put way too, the 2-inch mill and fill was way more than that road needed. And so if you think of that, you can think about it in dollars, that they wasted dollars by doing a 2-inch mill and fill when they could have done a chip seal or a microsurfacing or a cape seal or whatever. What I like to think of it is miles covered. And so if they spent double on a 2-inch mill and fill when they didn't have to, let's say they did 10 miles, well, they could have done 20 miles or 25 miles of something else and got more roads covered and more roads protected. The other third of the time, they didn't do enough. And so the 2-inch mill and fill wasn't enough. They didn't do what the road needed. And, rehabilitation, more patching, possibly milling, more, whatever that is. And then they looked at that and they determined that was really a triple hit because we did the wrong process. And then we had to repair it and redo it. And then we spent double, which meant that on the third side, that's even more miles we weren't able to cover with those same dollars if we would have done something different. So right treatment, right road, right time is, it's kind of it's that saying's been around a while, but it really nails what we're trying to do here. Okay, there we go. And we want to improve road user satisfaction, obviously. So again, why develop a preservation mindset? Your budgets, obviously. You guys know this. Few agencies can afford a strategy of build it, rehab it, and build it again. Bouzid could do that in Florida because he had a mouse giving him some money with Disney, but most agencies don't have that. So pavement performance, your FHWA performance thresholds are going to be difficult to meet without preservation. If you're waiting, if you're having to wait 18 years before you can afford to do another rehab on a roadway, those performance thresholds are going to drop and you're not going to meet them. Material changes. I don't know about your area, but every other location in the country that I talk to, your pavements aren't lasting as long as they used to. When I ask folks to tell me how long a new overlay is going to last them, around the country, I'm hearing 8 to 12 years. Is that about what you all are seeing, or are you getting better or worse than that? Okay. So preservation stretches the service life of these pavements. And then the other thing is sustainability. And I went in and we've got the Carbon Reduction Act and environmental product declarations. Washington State has a carbon reduction strategy. I went through it the other day. Was a little difficult to stay awake, but I did. And it was really interesting that there was nothing in that transportation carbon reduction strategy that said, hey, wouldn't it be great if we made pavements last longer and didn't tear them up and didn't throw them away by using pavement preservation? And there were all these other things to look at on a carbon reduction strategy. But in my opinion, if that's important to a DOT, then it's important to develop a preservation strategy, and I think that'll do a lot more than some of the other things that states look at on their carbon reduction. The other thing is when we think about sustainability, even if carbon reduction isn't important to you, our best aggregates, our best asphalts are already in your roads. And so by preserving those assets that you've already paid for, those aggregates, that asphalt cement, by recycling it when you can, and then preserving it again, that's sustainability. And nobody wants a new quarry. Nobody wants us to build new refineries, even though we have to. And so by reusing and protecting the value of what we already have is extremely important. The best reason is it works. I don't know if any of you have seen this slide before. It's been around a long time. The story is, so the center line of this roadway is the town line of two towns in Connecticut. In 2004, they came together. They both threw some money in and they did a 2-inch mill and fill. In 2010, the city on the right said, hey, we're learning about pavement preservation and we're going to do a crack seal and a microsurfacing. And the city on the left said, yeah, no, we're not going to do that. That's a waste of money. We don't believe in pavement preservation. So here's where we are. This was taken 6 years later in 2016. And just by slowing the oxidation and slowing the water intrusion on the right-hand side of the road, look what that's done to preserve that road. The section on the right, you could probably do another microsurfacing on it, maybe a chip seal, fill the cracks and probably let it go another few years. The section on the left, that's well beyond pavement preservation. That's getting into maintenance, rehab. Maybe you could do another 2-inch mill and fill, but my guess is we're down into the base asphalt. We've probably got some stripping in there. We've probably got some base issues down below. Whatever, though, that simple application of a crack treatment and a thin surface treatment protected that road, and that pavement on the right will last many more years than the pavement on the left. So why don't we just mill and fill everything? Well, let's talk about that. So we're going to look at one state. This is a worst first state, very overlay heavy. These are their 23 numbers that came off their website. They spent about $1.6 billion for what they called roadway preservation activities. They consider that capital preventive maintenance of usually mill and fills, and then highway, freeway, and non-freeway resurfacing. They covered, in 2023, they covered 2,138 lane miles of their 32,000 lane mile system, or about 6.7% of the network. So if you take that out, that's a 15-year cycle. So they get to a road in 2025 and they're not going to get to it again until 15 years down the line. But we've already determined that our pavements are lasting 8 to 12 years. So we already know we're in trouble. And because they're a worst first and they're not doing any light preservation, they're doing all heavy work. That $1.6 billion over that 2,138 lane miles was $748,000 per lane mile. I gave this to that DOT. I was down doing training because they were seeing this internally. That I don't think they'd looked at it this way, and they knew that they had to change. But I had a district engineer in the training raise his hand, and at first I thought, oh boy, he's going to tell me what an idiot I am. And he said, you don't understand. He says, my district at that year, we were able to touch 1% of our network. That's all they touched with anything. in 1 year was 1% of their network. He says, I don't know where we're going to go from here. I don't know how we can get out of this. So that's a place we don't want to be. Here's a team with a preservation mindset. Now, one thing I want to let you know, these miles are roadbed miles. This state tracks roadbed, not miles, not lane miles. So they improved 7,100 roadbed miles of pavement in 2023. That included seal coat or chip seal, microsurfacing, thin lift, and regular HMA paving. They have a large network, so 7,100 miles out of their 35,000 roadbed mile network. They touched 20% of their network, or they're on a 5-year cycle, if you look at it that way. And they had a mix of treatments of 60% chip seal, 20% paving, and 20% of other stuff, crack treatments, microsurfacings, cape seals, things like that. So this organization has got it going, except, well, let me get to this, but I'm working with them. It is Pennsylvania, by the way, and they did a study in 2025 and looked at their numbers, and two things stuck out to them. Number one, that they're actually went down from 20% miles touched to 17. They believe that was the fact that their overlays got so expensive in that time that they just had to do less overlays. And so they were doing as much preservation they were as before. They had to cut back on their overlays. But the other thing really important that they determined that when they separate their urban, well, I mean, not urban, when they separate their 2-lane, their smaller rural roadways, and then their high traffic, their interstate volumes, they're finding out that, yeah, we're hitting our 2 lanes probably more than 20% or every 5 years. We're probably doing something every 3 to 4 years with our crack treatments. But then when they looked at their expensive interstate pavements, they found out that they weren't doing anything. They were basically worst first on their interstate system. And they've looked at that and said, well, that can't continue because those are our most expensive roadways. And so working with them now to develop preservation strategies for those high traffic interstates throughout there. So very important. So a worst first rehabilitation program is not going to save your network. You will never catch up if you let it go far enough down. Deferring preservation maintenance does not save dollars. A balanced approach is next. So yes, you have to do rehab. You're always going to have to do rehab, but you have to have a balance of some preservation maintenance, and some rehab, and find a percentages that work for your state, and then stick with it. And what you'll find is the longer you have a preservation strategy, the better off you're going to be. Alabama DOT found out after about 7 years of a true preservation strategy that they were actually cutting their overlay budgets on their interstate and were able to use those dollars for sign rehab, ditch rehab, rest area reconstruction, things like that, because they didn't need to do that many overlays anymore. So that's where we'd like all DOTs to end up, I would hope, within the next 10 years. And that's what this study is really all about. So using planned lower cost treatments to extend remaining service life. I like to talk about preservation and preservation maintenance. And true preservation to me is placing a treatment that preserves the surface and extends the remaining surface life of the road. We're doing this on a road that is in good condition. Preservation maintenance is repairing surface defects, but then still preserving the surface and extending remaining service life. So patching really isn't preservation maintenance. Patching is just reactive maintenance. There's no preservation to that. True preservation is time-based. We're learning now that the quicker we put something on that pavement to stop or slow oxidation and moisture intrusion, the better we are. And we shouldn't wait until we see deficiencies in the pavement distresses before we do something. So preservation's early and often. Preservation maintenance is time and condition based. So you know you need to keep up with that pavement, you need to schedule it, you need to work to get up to that 20-25% touches per year, but you also have to be condition based. And so you place as early as possible when defects occur. We're adding service life, or we're stopping deterioration and adding service life. The best thing is these preservation treatments are generally less expensive. Preservation maintenance, the more we go down the curve, the more rehab we're having to do, the more aggressive treatment, it costs more. That's when our combination treatments come in, double chip seals, cape seal, a chip seal with a micro over the top of it, even some recycling treatments that help that. Now, the one thing that we got to understand is with all of these thin surface treatments, whether it's a chip seal all the way up to a thin overlay, an ultra thin bonded wearing course, none of them are designed for roads with structural defects. And a structural defect means either the pavement or the base below the pavement has failed. And so pavement failure is stripping, the asphalt no longer adheres to the aggregate. Potholes if they're not repaired, rutting if it's continuing to rut, longitude, very heavy longitude and transverse cracking. Those are pavement failures. And so any surface treatment is not going to help those. Base failures, alligator cracking, which means the base or subbase has failed, fines pumping, water pumping out of the mat. Those are structural. These pavement preservation processes should not, well, they can be used to buy time. They can be used, like in this case, but it's not pavement preservation. With a functional distress, which is what we call a surface distress, chip seal or microsurfacing or any of these thin treatments can be used to treat moderate functional distresses. A functional distress, if not treated, becomes a structural defect down the line. A functional defect is often caused by environmental or traffic conditions. It can be rutting. If the rutting is stopped, then we can do something with it. If we've got bleeding or flushing, longitudinal and transverse cracking that's light to moderate, polishing and raveling, those are functional issues, functional distresses, and that's where pavement preservation processes shine. We learn a lot from roadresource.org. This is a website that was put together by the PPRA, which is a affiliation of the International Slurry Surfacing Association, the Asphalt Emulsion Manufacturers Association, and the Asphalt Recycling and Reclaiming Association. And if you've not been to roadresource.org, there is tons of information there on pavement preservation, treatments, on network optimization, pavement preservation, recycling, all sorts of stuff. So I really recommend that you use this source. It's really good when you bring in new folks that haven't been introduced to pavement preservation, and they can spend some time on this website and get up to speed really quickly. Some other great documents we have is the NCPP Chip Seal Training Guide, and you can get that on our website, which is pavementpreservation.org, or the QR code I'll leave here for a second. And I checked it this morning. It does work. So every now and then those kind of fail. Let me get a drink of water here. Another great guide is the FHWA Chip Seal Checklist. They used to send these out in a nice little flip form. It was kind of a plastic coated flip chart that worked really well. Well, they don't do that anymore, so you got to just download it from this site, and you can pick that up here. You can pick it up from the FHWA. They have these for chip seal, fog seal, microsurfacing, all. I think there's 18 or 19 different pavement preservation checklists that you can download. There's also a fog seal checklist. We're doing a fog seal on this chip, I believe. And I found another one. I kept this in here because I did do some training. We did some training for the Alaska DOT. Like Todd said, they had their project a couple weeks ago, and they actually have a very good document on their website, and you can just Google that, Alaska DOT Asphalt Surface Treatment Guide. There's a lot of it that's extremely similar to our NCPP guide, but because you all in places have a climate that's similar to some places of the Alaska climate, I think this might be helpful for you all as well. So I don't have a QR code for that, but it's easy to find with Google. Okay, so project selection and preparation for payment preservation here. We're not going to go too deep on this, but as a designer, if you're designing a preservation project, the number one thing you got to understand is the intent of this preservation. So do I have a road that's in good condition with no defects or very few defects, and I want to keep that in good condition for another 5 years? Is that my intent? Or do I have surface defects that I need to repair first and then to, preserve that road for another 5 years? So what's my intent? Do I have any untreated light to moderate cracking? So do I, we always want to crack seal first. I don't remember if I get to it, but the NCAT PG2 study showed that sealing cracks is probably the most cost-effective way of preserving a roadway, and that a road that's been in good condition, crack sealed, stays in good condition for at least 12 additional years. Do I have untreated rutting? So more than a 1/4 inch. Those cause issues for some preservation projects. So I need to understand what kind of rutting I've got. Do I have isolated base repairs, or do I have a whole bunch of base repairs? What's the most cost-effective way of preparing this roadway for preservation? Is a chip seal feasible for this location? You may not go through downtown of a mid-sized city with a chip seal. That's probably not a place where you can do a chip seal. But there are a lot of you all, I've seen from what I've read, you all use a lot of chip seal, and that's great. There is no better preservation process than a chip seal when done right and when the road is selected correctly. But traffic's tough, night work can be tough, high speed can be tough, and then again we've got that political thing: is can we put a chip seal there without causing hate and discontent with the bicyclists or the neighbors or whatever. So, but that's a good go-to. If it's preservation maintenance, so what are the primary and secondary distresses that I need to take care of? Is it cracking? Is it rutting? If it's a lot of minor cracking, can I take care of that with a scrub seal rather than having to go out with a crack filling crew and get them dizzy going all around and filling all the cracks? How do I want to do that? How quickly is the deterioration happening? Is that road falling apart quickly, or have we just had a few cracks in the last few years, and so maybe a lighter preservation treatment can really help that and keep it going? Is a pavement dry and oxidized or flushed and slick? That makes a difference on what treatment that you select. Is there light, less than 1/2 inch rutting, more moderate rutting, more than 1/2 inch? Okay, so we're going to go into chip seal selection. And again, we are talking best practices here. And there are times in the field where you all as engineers may need to make decisions based on budget, based on need, based on political issues. And so, but from now on, we are talking best practices and how we hope that it can be done. And so good candidates for a chip seal are minor cracking, raveling, loss of fines, some flushing. To me, that photo is maybe a little heavy, but on the flushing, but we can do a good job with the chip seal, reducing the effects of flushing, probably not bleeding. Oxidation is perfect place for chip seal, and then loss of friction. So very good use of a chip seal. Unacceptable candidates, and is a rutted pavement if the ruts have not been repaired. And this is a great photo of the rutting, and this photo kind of tells us why rutting's not a great candidate, while chip seal is not a great candidate for rutting, because your asphalt emulsion is going to act somewhat like this water, or a lot like this water. And if we don't do some things, which we'll talk about later, chip sealing on this rutted pavement, we're going to have asphalt emulsion where we don't want it, and our embedment's going to be too high, and we could have bleeding and other issues. So rutted pavement that's not repaired is generally an unacceptable candidate. The other thing is a poor ride. And you guys understand this, is if you got a bad ride and you put a chip seal on it, you're going to have a nice chip seal with a bad ride. There's nothing we can do to fix that. Untreated cracks greater than 1/4 of an inch, we want to treat. We'd like to treat all the cracks, but definitely anything over 1/4 need to be treated before we chip seal, because that chip seal emulsion will not seal that crack completely, and it will allow chip seal aggregate into it, another aggregate, and that crack will grow over time. And obviously this is a little over the top, but structural issues, obviously a chip seal is not going to fix them. We can put one on it, but it's not going to fix it. We can glue it together for a while. Another thing is this fatigue cracking. So again, this fatigue cracking is from the mix, from the bottom. It is not top-down environmental cracking. This is fatigue cracking. Chip seal is not going to fix this. We can use a chip seal over it to seal up those cracks, but we're not fixing the underlying problem. And I'll also, you can look at this. I think we've got rutting that's going along here as well. Without a straight edge, it's kind of hard to tell, but I'm pretty sure there is a rut there. So that wouldn't be, you can do a chip seal there. It's probably not going to be a failure, but you're not fixing any of the issues that you have. So preparation for all preservation projects are the same. Early stage is our crack treatments. We really want to crack treat before we do a preservation process. We really like to have that done at least 30 days ahead of time if we can. We like to get traffic on that crack treatment, get it leveled out a little bit, get it down into the crack, and so we don't have humps. We want to make sure that our overbands on our crack treatments are thin, within about 1/8 of an inch thickness, and so we're not leaving a thump on a chip seal, or we're not picking it up with a microsurfacing spreader box. Any structural leveling or full depth repairs need to be done. Tree trimming, herbicide treatment, edge milling, micro milling for either adhesion process, or to help the adhesion of the preservation, or to help the ride. So those are early stage. That stuff should be done well before the contractor shows up to do the preservation project. Final stage is surface cleaning, structure and casting protection, pavement marking removal. If you always want to remove thermoplastic and buttons. Paint's not generally removed unless it's very thick. And then pre-tacking prior to seal. There's some states, Minnesota does that right now. They pre-tack their stripes before sealing, and they find that they get a better life of the chip seal by doing that. We also have gutter protection and railroad crossing protection. Another final stage preparation that I don't have on here is if we've done hot mix patching as part of this process, and we've got fresh patches where we're going to chip seal, it's really a good practice to fog those patches prior to doing the chip seal, because you would think that a new asphalt pavement is going to require less asphalt for the chip seal, but actually it does. they will absorb. And so your embedment will be lower on those patches if you don't put some sort of fog seal. And just a light fog just before application of the chip seal is worth it. But I know we're having some base repairs on these projects, and I would highly recommend that we fog seal or tack, however, whatever term you want to use, those patches beforehand. Crack treatments should always precede a surface treatment. We like to see them completed at least 30 days prior. Overband thickness less than 1/8 of an inch. If you're using mastic, it's a great product under pavement preservation processes. We want those usually to be flush or slightly below the surface. We need to remember with any of these thin treatments is we can kind of level a dip or a low patch or a low crack or whatever. We can kind of level that a little bit. But if your maintenance application of whether it's a patch or crack treatment or mastic makes a bump, we're going to have a bump when we're done. There's nothing we can do about that. So we want to be careful with all of our patching or crack treatments. I think we talk about that here. We talked about completed 30 days prior, fog seal, left flush or slightly below the surface. Ride quality of leveling and patches must equal the desired ride quality of the finished pavement. We can't fix rough patches with these thin treatments. And we talked about that. A bump's always going to be a bump. Like I say, folks are starting to use, we've been doing edge milling on curb and gutter sections for a long time, where we just take right there at the curb wall, mill down 1/2 inch to allow the treatment to blend right in, and then out maybe 4 foot to daylight or 6 foot to daylight, depending on the mill. But we're also starting to use micro milling heads, which we see there on the left have just a whole bunch more teeth than what we're used to seeing on a normal rotomill. And you can see that's a very fine milled surface, and it really it helps the preservation adhere. It takes away some of the rutting. It takes away some of the roughness. It's a good treatment to do underneath your preservation treatments. So I think we're at this is a good place for about a 10-minute break. So let's see what we got here. It is, what is it? I got to get my clock right. 9:25 for you all. Let's come back at 9:35 or 10 minutes, and we'll get back into it. And we'll get into chip seal. So thank you. We'll get going in 1 minute. Okay, we're going to get started again. Todd, first of all, I had to turn a fan on, so let me know if the background noise gets out of hand, and I'll turn it back off. Um, Joel, I think our project lead, Joel Uhrig, is joined us. Joel, you want to say a few words and welcome these folks, or you want to wait toward the end?
Oh, this is fine if you can hear me.
Yeah, absolutely.
All right. No, I just want to say welcome everybody, and yeah, really appreciate you guys, taking advantage of the training here that Rex is putting on. This is top notch, so we really appreciate that. Yeah, really excited, I guess, as far as the PG3 project progresses along, that you've come to this point, and yeah, look forward to continuing to work with you. So thanks, everyone.
Very good. Thank you. I wanted to wait for you, but Bazid said no, get going. So that's whatever. Anyway. Anybody else join with you, Joel, from your team?
Yeah, it looked like Eob was on and
Eob?
Ed Johnson.
We got Eddie. Eob, you want to introduce yourself, please?
Thank you, Rex. Thank you, Joe. Yes, I am here. I've been following this group for some time now. I find this discussion and this presentation very, very, very helpful. I have not been working on payment preservation in particular, but until last year. But now, thanks to Joe guidance, Ed Johnson here, I'm trying to catch up and trying to become as a group as a champion for this technology. So thank you again. I think
Thank
Ed is
you.
also here.
Yes, we got him. Thank you very much. All right. So why a chip seal? And I understand that your department uses a ton of chip seals and uses it for a lot of things. If I remember right, one of these roadways is, I don't think, much more than chip seal, and it's been around for 60 years. So obviously they did something right on the base, and they protected that base, and they kept protecting it with chip seals. Comes to a time when maybe that's not enough, but chip seals help preserve the pavement by protecting the surface asphalt from oxidation. Oxidation is caused by sun and chemicals, makes the asphalt cement brittle and more prone to cracking and raveling. And now, with the way our asphalt cements are, they don't handle, they oxidize quicker, they get more brittle faster. That's why we're seeing a lot of cracking. And so the chip seals help slow that oxidation. They can't do anything with what's been oxidized out of the asphalt plant, but they help the pavement oxidize slower once we get something to protect that. And then it protects the surface and base from moisture intrusion, which we obviously know is important, because that moisture causes stripping of the base layers, potholes, and base failures. And so the other thing that we kind of forget, water has oxygen in it, H2O. And so when that water gets into the layers of asphalt as it gets through the surface into the layer of the surface course and maybe down into the next level, it is oxidizing that pavement as well. And so it is helping to harden the asphalt just by getting water in there. The other thing it does is it does provide a skid resistant sacrificial surface that protects the underlying surface from traffic wear and damage. And so maybe that when you're doing chip seal over chip seal, that's not important. But as we put this onto a newer HMA as a preservation treatment, and we've got that skid resistance, we have a membrane that is truly waterproof and air, it's not allowing air and oxidation to hit that expensive surface course. And it's okay if that treatment doesn't last forever. If we think about it as a sacrificial wearing surface. Now, we want it to last as long as it can. I'm not saying 1 year for a chip seal is okay, but if we plan on it lasting 7 years and we get 7 years and it wears off, it's done its job and it's time to do something else. And so chip seals are just, again, to me, are the best treatment. It's that single layer of asphalt binder that is covered by embedded aggregate, 1 stone thick, whose primary purpose is to seal the fine cracks in an underlying pavement surface and prevent water intrusion into the base and subgrade. And we've kind of hit most of these. It's good, provides good skid resistance when done correctly. It's very cost effective. Chip seals, very cost effective, good durability, especially if we use really nice durable aggregates like what we're going to talk about coming up. And then construction, ease of construction. They're done rapidly. They don't take a ton of equipment. They do take a lot of skill. It is an artwork, but they don't cause a lot of traffic disruptions, and so it's just a really great process. And I'm an old microsurfacing guy, and so for me to talk up chip seals this much, you need to understand I do think they're a great product. We've talked about most of this, but the good thing is, and you guys are learning this, you're using it now. Chip seal can also be an effective form of minor, maybe not much more than minor, but minor rehabilitation. And especially if we double stack a chip seal, or we use a chip seal before as a cape seal, or even some parts of the country are using chip seal as an interlayer below their hot mix, and so it works really well for that as well. So a lot of reasons to use a chip seal. Oop, that one doubled in there. So we're arresting raveling. Talked about that. New wearing surface friction. I think that's one of Todd's chip seals there on the lower left. One of the limestone seals in Indiana. So helps that surface appearance. However, we got to remember, a chip seal does not add structure to a road. If you have a bad road before, you're still going to have a bad road after. So we just have to realize that when we're choosing these roads to put a chip seal on. Just love this picture. I stole this from somebody out west. They're doing everything right here. This may be a hot rubber chip seal, it may not be an emulsion, but they are right behind that distributor, getting those chips on before it has time to break or cool, depending on the asphalt, liquid asphalt that we're using. Love it. Got the American flag there, makes me happy. So got a little video here. Turn the sound off. I didn't get the distributor in this one. This is one of Joel's projects up in northern Minnesota, but you can see, if you've not seen a chip seal, that is the full width application of the chips over the aggregate or the asphalt membrane. Oh, don't need to see that again. And another one here. Oh, shown there on the chip box with that joint there, looking really good. The crew did a good job up there. And one more. This is a scrub chip seal, so they are scrubbing this in, but you can see how that scrub broom is filling in the cracking, and how the distributor and the aggregates chipper are close together, and that is one of the main best practices that we have. And as we get forward with you all doing a chip seal in rutted pavements, this becomes even more important, and we'll talk about why as we get going. Gotta hit the right button here. And one more. So the chipper pulls up and grabs onto the dump truck. Let's make sure they're latched. Communication is good. You can see the rollers right up where they should be, right caught up. So we're going to talk about rollers and how often they should roll. And oh, sorry about that. I hit the wrong button. Go to the next one. Okay, as we move forward, I want you to think of the term embedment. And that is the most important part of a successful chip seal is, did we get the stone embedded correctly into the asphalt membrane? That's the whole thing we're trying to do here. We have sprayed an asphalt membrane at a certain thickness, certain gallons per square yard. And we want to make sure that our aggregate gets embedded far enough into the membrane so that it's held by the asphalt and won't come off when we roll it, broom it, or even worse, when people drive on it. But we can't be embedded so much that there's a chance that when it gets hot or when traffic hits it, that we're going to either push that stone further into the membrane or have the membrane swell up a little bit and overtop the stone, because then we have flushing and bleeding. And so whether we lose stone because of not enough embedment or we overtop the stone with the asphalt, it ends up being a flushed chip seal, which gives us issues for friction. It's ugly. It can pick up if it's really bad. I've had chip seals where if traffic would stop on it, and if it was very flushed, the traffic could actually pull up the overlay from the next layer, and that's bad form when that happens. So we want to shoot for best practices that after the chip seal has been open to traffic a few days, we're looking for somewhere in the range of 70% of that chip, or a little less, no more. 70% of that chip is embedded in that asphalt membrane. And that's after a little bit of traffic is on it. And so we need to think that during construction, we then know that we're probably looking for, after the rolling, after the final brooming, but before we open it to traffic, we better have at least 50% embedment at that time, maybe 50 to 60. If we have less than 50%, we're probably going to have chip loss. And if at that time we have more than 70%, we're liable to have a flush chip seal with asphalt emulsion or asphalt cement overtopping the aggregate. So everything we're going to talk about from now on leads us to embedment. And so that means the materials that we use and all of that, and all the best practices that we have. That's our goal. So everything that we're going to do, that your contractor is going to do out there, everything that your materials group has done, if they, I don't know, if I can't remember if Washington DOT does the chip seal design or if the contractor does that, but everything done in the material section and in the application affects embedment. So the emulsions, the aggregates, the equipment, how the distributor operates, how the chip spreader operates, how we roll, what we roll with, brooms, those make a difference. There's application best practices. And then the existing pavement that we're putting it on has something to do with the embedment. Let's talk a little bit about emulsions. We're not going to go too deep. I do want to let you know that if you want to learn more about emulsions, that roadresource.org website is excellent. There's a whole set of chapters on emulsion, and it's very good. So asphalt emulsion is a chemically stabilized dispersion of fine asphalt particles dispersed throughout a continuous water phase as a carrier. And we've got a little micrograph of what that looks like. And you see we've got all these particles that are roughly the same size, and what we want an emulsion to do is we want these little particles of asphalt to stay away from each other while we're pumping it and while we're storing it and while we're transporting it. And then we want, whenever we want those particles to all come together and stick together and stick to either the aggregate that we mix it with, or the road that we spray it on, or the aggregate we drop in, we want it to then break, set, and cure, and release the water and let the asphalt particles grab onto whatever we want them to grab onto, and then become traffic ready. And that's how an emulsion works. So why do we emulsify asphalt? Number one, asphalt cement can occur naturally, or it's refined from crude oil. And so picture on the left is in Trinidad, Tobago, a little Caribbean island north of Venezuela. And that's actually a lake of asphalt. And these folks are blessed to own this. And every day they go out with a track excavator and they dig up some asphalt, whatever asphalt they need that day to process. And the next morning they come back and the lake is back at the same level it was the day before, and they do it again. And they produce that, they turn that asphalt into all sorts of asphalt emulsions, asphalt cement, and it's used in that region. For the rest of us that don't have a lake of asphalt in our backyard, we have to use crude oil. And you'll see the crude oil slate there, the crude slate that as we heat that crude oil at different temperatures, the lighter ends go off, the lightweight gases go through, and the naphthas, gasoline, kerosenes, different gas oils, our lube oils, everything. And then finally at the bottom of the barrel, which is what we are, at the bottom of the barrel is the asphalt. And that's where it comes from. And so one of the problems why our asphalts aren't lasting as long as they used to, one is our supplies. The Canadian oil sands don't seem to make as good of emulsion and asphalts as other ones do. But also the refiners have learned how to get more of the expensive stuff like gasoline out of that column, and they've left less of the goodie in the asphalt. And so that's one of the issues why that's why we're oxidizing quicker and having issues with that. So why do we emulsify it? Well, you'll see there that asphalt cement needs to be at somewhere around 380 degrees to be able to pump it, move it, mix it. We don't like doing that. We would like to be able to pump that product at ambient temperature, mix that product at ambient temperature, and not have to have it at 380 degrees for a lot of reasons. Number one, that extra heat can damage the asphalt. The safety issues are huge, and how you can do projects in remote areas and have to heat that material. So that's one of the reasons why we're emulsifying asphalt. Again, it's a homogeneous mixture of two immiscible liquids, and that's hard to do in a presentation. So homogeneous means they're all together. You don't see any separation in that photo there. Immiscible means they don't normally mix: oil, asphalt, and water. The manufacturing process is pretty simple. We take what's called a soap solution, and that's the term that's used, that it has water, emulsifier, which the emulsifier, for lack of a better term, acts just like Dawn dishwashing liquid. And that's why we call it a soap. Some of them are very similar to soap. And then, so we'll take that water, that emulsifier, and the asphalt cement goes into a colloid, what's called a colloid mill. I think I've got a picture of one of those coming up here. There's an emulsion plant. Here's a mill. And so that asphalt cement is injected into this mill. The stator and the rotor are microns apart, and that stator is traveling at sometimes up to 12,500 RPM. And so what we're doing is we're slicing those asphalt particles and turning them into little droplets, very fine droplets of asphalt. And then we're injecting that soap solution into that, and that emulsifier coats all of those little bitty baby particles of asphalt with the emulsifier. And so go back here. And then we pump it into the tank and we can store it. So if you look here on the upper right, we can see those little globs of asphalt floating around in a water phase. And each one of those globs, as we can see in that little drawing there, is coated with an emulsifier. And there's that emulsifier's got a tail and a head, and we've got negative and positive there. And so by being coated with those positive ions there, and they're all positive, that means, well, we know we need opposites to attract. And so if everybody's a positive ion, they're going to sit there in that tanker or in that storage tank, and they're just going to bounce around happy as can be until we add something to it, the aggregate, that causes those positive, that makes those positive ions go to something that's a negative charge or a lesser positive charge. And so that's what we're doing with an asphalt emulsion. I don't know, that one's kind of a little bit more on the colloid mill. An emulsion plant is not a big operation. An emulsion plant, company I used to work for, we had one in a 40-foot shipping container, and that and some plastic tanks and a water source, and you are in the emulsion business. Talked about that. The emulsifiers and additives that we put into the emulsion, and they can be latex for flexibility. We'll talk about that. There's all sorts of different chemical packages that the emulsion supplier will use. And what that does, again, is it stabilizes that emulsion. So we don't want it to separate until we want it to. And then it gives it, its curing characteristics, and it does things to help it grab onto the aggregate differently or better. So it's very important. And what I like about emulsions is we can really, or they can, I can't do it. The manufacturer can really tailor an emulsion to the job you're doing, the aggregate you're using, sometimes even the contractor. They can make changes that this contractor needs that another one maybe with their process doesn't. So really interesting stuff. There we show those little particles bouncing around because they're all positive in a water phase. And then that aggregate particles is either negatively charged or very slightly positive charged. So all those little positive ions that are coated around the asphalt particle are now attracted to that aggregate, and that asphalt particle now will move and grab onto that, and boom, we've got what's called the chemical break, where the asphalt cement is now turning from an emulsion into asphalt cement. It's grabbing onto that aggregate and it's building strength like what we want. So this asphalt, again, the asphalt is no different than the asphalt that you're using in a hot mix HMA project. It may be the same asphalt, it may not be, it may be better, but where they're using heat, we're using water. But once that water is out of the system, you're left with a asphalt surface treatment, just like if it was a hot mix overlay. Emulsions are not inferior to hot mix paving. So chip seal emulsion, most of the time, most parts of the country are using what's called a CRS-2P. Let's talk about what CRS-2P means and why it's important to the embedment. Number one, C means cationic or positive charge. And so we saw in those little diagrams that that was a cationic emulsion because the coating of emulsifier had a positive charge to it. There are also negatively charged emulsions that would be an RS2P. We find that the cationic emulsion, because of the aggregate charges that most places have, that most aggregates have, that a cationic is going to grab that aggregate quicker and build strength quicker than an anionic emulsion, one that's a negatively charged emulsion. But there are places where that anionic emulsion works better with the aggregates that they have. But I think we're using a CRS-2P. The RS means rapid set. So set means how quickly is the water going to start separating from the asphalt cement particles? How long is it going to take till asphalt starts sticking to each other and starts sticking to the aggregate or the roadway, whichever we sprayed it on? So we want a chip seal emulsion to be rapid set. The reason is there's a couple reasons for that. One, if you think back to that picture we showed earlier of the rutted section. And so we're putting this material, we're spraying this on a roadway that's got a slope to it. It's got a side slope. However many degrees you guys have your slope on a roadway. You might be spraying it up a hill or down a hill. There might be some ruts. And you want, when you drop that aggregate particle into that membrane of asphalt emulsion, you want it to start grabbing that rock immediately and going from a liquid to a solid so it doesn't have time to run off the road. If your 12-foot wide membrane spreads out to 12.5-foot wide because it won't break, set, and cure, well, then your embedment's lost. And so we have the emulsions come in rapid set, medium set, slow set. There's a quick set usually used for slurry or microsurfacing. And we want that rapid set for chip seal because we want that chip to be dropped in that membrane and we want that asphalt particle to grab it immediately and keep it in place. 2, higher viscosity. And again, that's really important. So a 2 means that the asphalt emulsion is, generally a way to think about it, is thicker than water. And if it's a 1 or there's no viscosity number there, that means it's water. It's about the same consistency as water or even possibly a little less viscous. With a chip seal, again, we want a high viscosity. We don't want that. We don't want to spray that membrane and then have it try and roll off the road. We don't want to spray that membrane and then have it puddle in the bottom of the rut before we have time to drop the chips on. And so I think for our contractor and for you all to think about, we probably want to talk to our emulsion supplier and go, hey, we are chipping ruts. And we probably need to make sure that asphalt emulsion you send us is at the higher point of the viscosity. And what that means is you'll have more residual asphalt in that material than not more, but it'll have higher residual asphalt so that it won't run off into the rut quickly. So it'll give you time to stay where it needs to be while you get the chip dropped on. And then H is made with a harder base stock, and that kind of helps with that viscosity as well. And then P is polymer modified, and those polymers, the polymer coats that asphalt particle while it's in suspension. The polymer stays, and it stays in the asphalt and then wraps around the aggregate. Polymer does a couple things for a chip seal. Number one, it acts like the antifreeze in your truck engine, in that like if you put coolant in your radiator, it lowers the temperature at which that water is going to freeze. And so where it would normally, if you just had water in your radiator, it would freeze at 32 degrees, and you put the right amount of antifreeze in there, it will not freeze till, I don't know, -20, -30, however much you put into it. And then also you have coolant. And so if you just had water in your engine, it would boil out at 212 degrees. And you put the coolant in, and it changes the boiling point of that liquid up to whatever it needs to be, 240, 250, whatever that number is. Well, it does the same thing with asphalt. And so that polymer changes the temperature at which the asphalt gets brittle. And so where there may get brittle at -10, it's not going to get brittle to -30. And if it's going to move and push and shove at 135 degrees, adding polymer may give us road temperature of 155 before it starts to move and shove on us. It also can add strength to the asphalt aggregate bond. So I'm glad you're using polymers. So that kind of gets us with that bituminous binder. And again, we've talked about emulsion. We can also use hot applied asphalt cement for a chip seal, and those work very well as also, but we're kind of concentrating on the emulsion. And so here again, we've got our membrane of asphalt. We have our aggregate that's embedded in that, and that's what we want. So let's talk about that aggregate. And number one is we really want a mostly single size aggregate, like shown on the bottom there. We don't want the dense graded aggregate, which means that we have aggregates retained on all of, or many of the sieves going through from 200 to 100 to 50 all the way up to 3/8 inch. And you can see there, if we have lots of different size aggregates, then we don't have the embedment that we want. And so you can see those little chunks of, I don't know, 30, 50, 16 falling down into the membrane, and then they're holding up the 3/8 inch stone, so it's hardly embedded at all. And then also it's kind of those are pushing some of that asphalt membrane up, and so it's overtopping some of the other aggregates. And so that dense graded stone right there is going to be a poor quality chip seal, and you have a good chance of having a flush chip seal. Again, either because you lost your stone or because the stone was overtopped by the asphalt membrane. Thank you. So on the single size, you'll see that we don't have any of those little stones in there holding up the bigger stones. We don't have any small stones that are going to get overtopped. And so that's really important when you look at your gradation. We get our best aggregate performance on a chip seal when we have single sized with minimum fines. The fines that we have need to be clean. It's okay if they're rock dust. We can't have silt or clay fines, free of clay. That single size aggregate, we want it to be as cubical as it can be. If it's rounded, it's going to roll around. So we definitely need crushed faces, and we would love to have every face crushed and at least two sides crushed if we can get that. We want it to be abrasion resistant. So the LA abrasion test is important because that aggregate is the only thing between the tires of the vehicle and the asphalt membrane. And really the only thing that aggregate's doing is protecting the membrane. It needs to be a tough, hard aggregate that's not going to degrade under traffic. binder compatible. So it needs to, if we have an aggregate that has a positive charge, maybe we want that anionic emulsion. And if we have one that has a very low positive charge or a negative charge, we probably want the cationic material. So it's important that we check in the lab that our asphalt emulsion is compatible with our aggregate. If we're doing an emulsion chip seal, we want that aggregate to be damp, not wet, just damp. But if we're doing a hot applied chip seal, that aggregate needs to be bone dry. In fact, most folks doing hot applied chip are doing they're pre-coating it with either an asphalt emulsion or a hot asphalt cement, so that they can get it dry and they know that there's no asphalt in that aggregate. So the one thing I think as an inspector to look for is when you test your aggregate, is you need to make sure that it is clean. We like to have on the -200, 0 to 1.5% is usually our maximum of the -200, and then we need to make sure that any fines that are in there are not clay fines. It's rock dust. We don't get too deep into chip seal design. Basically, a chip seal design means we are determining target emulsion and application rates. And we do that by looking at, we look at the aggregate. We look at what the best embedment for that aggregate is. And then, okay, we look at that and then we say, okay, so in order to get 70% embedment, how many gallons per square yard do we need to shoot? And then we also need to look at the roadway. Is that roadway dry and oxidized? Well, we probably need to add a little bit to our emulsion shot. Is it slick and flushed? Well, again, we probably need to reduce some material from that design. If we have high traffic, we might need to lower our application a little bit because that traffic might want to push that aggregate into the embedment. Or if we don't have much traffic at all, we might need to bump it up just so it stays. So chip seal design, there's the Kirby, there's a modified Kirby, I can't even think about what the other one is, but they really want to look at how the materials are going to react, how much the road is going to drink, how dry is the pavement, and that's what determines our application rate. You guys doing okay out there? Any questions? Okay, let's talk about equipment. So asphalt distributor, we have a checklist here. The good thing is, we'll just get into it, but pretty much every distributor in captivity anymore has all of these. 15, 20 years ago, you could get distributors out on a job that weren't computerized and didn't circulate and didn't have a radar, all this good stuff. But pretty much now they're going to have this. Now, does that mean it works? No, that's you as an inspector. That's your job. So it should have a computer. A computer on the distributor watches the pump, watches the speed of the pump, determines what bars are turned on, and then makes a bunch of calculations. And it says, well, if the contractor wants 0.32 gallons per square yard and they want to drive at this speed, at this width, then I need to run the pump at this speed to make sure that we get the right membrane of asphalt on the road. They need to circulate between the tank and the bar, just so that if we're circulating, we know that what goes out, what gets sprayed, we can measure that. We need a working radar, or some of the brands don't use radar. They use a transmission meter, but we need to know how far and how fast we're going. That's very important. We need to have a working thermometer. We'll talk about temperatures here in a little bit to spray. We need to be able to heat sometimes. Sometimes it comes in, the asphalt emulsion doesn't need to be heated. Sometimes it does. And so we need a way to heat without burning that emulsion. Need a gallon gauge and a calibrated dipstick. We need correct tips or nozzles for application. There's all sorts of different nozzles, and depending on what rate you're spraying, what viscosity you're spraying, what material you're spraying, there are different nozzles for different applications. And the one thing is if we're not cleaning our strainers, we're getting clogs of asphalt emulsion. We're getting clogs in our nozzles. The computer doesn't know that. It thinks you're spraying what it's telling you to spray. And if that material can't get through the system and out the nozzle, you're not getting what you think you're getting. So why you should check your distributor's calibration. And this is really important. On a previous project that NCPP worked on with AASHTO, we did some projects with the new AASHTO chip seal spec, and we had states that put projects out there, and it was really interesting that that spec requires that the contractor calibrate the chip spreader and the distributor within days of the project, and they need to provide that calibration to the state. And one of the things that we heard back from our states that implemented this spec is, well, our contractors don't know how to calibrate their distributor. And we weren't able to get that done. And so we need to make sure that on this project that we're checking our distributor's calibration. And we're doing that because we want to make sure that the computer rate matches what's being sprayed on the ground. We want to make sure that we don't have bleeding or flooding of material, but we also want to make sure there's enough material there to retain the chip and assure a good bond. The fact that we're doing chips in rutted sections, I think that makes it even more important that we know exactly how much asphalt emulsion is going on the road. One of the things that, a distributor calibration is a little different than maybe a calibration of an asphalt plant or a microsurfacing paver, that there's things that you look at that you maybe wouldn't consider calibration. But one of those is sprayer nozzles at the same angle. And it's vitally important that those spray nozzles are at the manufacturer's recommended angle. Etnauer and I believe Bearcat, which are the main players in the distributor market, are 30-degree angle. There's other brands that are 15. It doesn't really matter what the angle is. It matters that you're using the angle that the manufacturer requires and that all of the nozzles are at the correct angle. Now, some contractors will take the end nozzle and put that at 90 degrees perpendicular to where they're shooting, so they get a crisp edge. That's fine. But other than that, we don't want all different angles, because what we're going to get is we're going to get a spray pattern like the one on the right, which we don't like. We want a triple overlap. So basically what that means, I don't have a good pointer on this system, but if you look at the black area, you're getting spray there from 3 nozzles. And that's what we mean by triple overlap. And if all the angles are the same, we're going to get that triple overlap. And that tells us that we're getting the material that we need there. If you look at there where you've got the different angles, you're all over the place. You've got some sections that don't have enough asphalt. You've got other sections that have too much, and you're going to have a mess there. Pretty easy for the contractor to check. It comes with a special wrench. You turn the wrench, it hits the nozzle next to it, and it gives you exactly that 30 degrees. The next thing to look at is bar height. And most distributors are designed that to get that triple lap coverage, the spray bar needs to be plus or minus 12 inches above the ground. And there's some folks get all concerned about, well, when the distributor's loaded, it could be at 11.5, and then as it sprays its emulsion, it raises up, and pretty soon it gets to be 12.5. we're building roads here. We're not building rockets. So I wouldn't worry about that. But the way to check this is if you have the contractor leave a nozzle on, like if you look at the second one from the left there, and then turn the next two off, and then spray the fourth nozzle from the right. If you spray those, you'll see, if you look at the drawing, that those fans touch. If those fans oops, didn't mean to do that. If those fans touch, that means you're going to have a triple overlap when you do everything else. And so again, plus or minus 12 inches, yes, it's going to change as the weight in the distributor changes, and it's going to change a little bit depending on the road surface and all that. But that's all good. So again, if our spray bar height is off, if we're either way, we're either going to have streaking because the spray bar is too high, and we have ridges of asphalt that are higher, that have more application rate than others. And so those ridges are an issue, but also just as important is the areas that don't get enough are low on asphalt. And so you've got embedment problems there. If your spray bar is too low, you're going to have sections again that are lighter than others. You're going to have gaps in between that triple overlap, and you're going to have issues that, thought I had a picture of what that looks like. Maybe it's coming up. So, calibration is important. We don't really want to, even though those distributors have a gallon gauge on them, they also should have a calibrated stab stick or dipstick. What the operator will do is you drop that calibrated stick down just to the top of the material in the tank. We don't want to dip it into the tank. And then we can measure up to normally a known point on the manhole there, and that will read how many gallons are in that distributor. And so we want to make sure the distributor is as level as possible to do that check. And so the spray calibration is pretty simple. You get a volume either by weight or by volume of the stab stick at the start. You spray a known distance with a known width, and you get so you can determine your square yards. You weigh and or stab stick the distributor at the end of that, and you get a gallons per square yard. And then you look at what the computer was telling us, and hopefully those are well within a 2% range, and you go on. If they're way off, there are ways in the manual for the distributor that you can look at to make the contractor can make changes to the calibration to make it work. Now that's spraying the distance, but the next thing is well, we want to make sure that if we want 0.32 gallons per square yard, we want 0.32 gallons per square yard on the left edge of the road, in the center of the road, and the right edge of the road. We want to make sure that we have a longitudinal rate check. And so we also do this same test with the chip spreader. And I kind of got my slides all mixed up, but something got off there. I apologize. But anyway, what we do is we'll put in our pads. Some folks use roofing felt. Some folks use Petromat. There's all sorts of things, and we want to put pads out that are, it'd be great if they could be 1 square yard in size. Sometimes for emulsion that gets a little heavy. So as long as it's a known square yard of size, and we put them across, and we spray, and then we weigh each of those. And we want to make sure that, again, if we're shooting for 0.32 pounds per square or gallons per square yard, we get that all the way across the rate. Nozzles matter. There'll be a slide rule or a computer app that the contractor will use that will help them determine what nozzle to use. You also want to remember that a distributor that's being used for tack, the nozzles are not what you want for chip seal, and those aren't the nozzles that you want for fog seal. And so that does matter. We want to look at, we talked about shot rate adjustments due to pavement condition, and we'll see here with a flushed asphalt surface, we need less asphalt emulsion. So, excuse me. So we might cut our shot rate down by 0.03 gallon per square yard. If we've got a smooth, non-porous surface, then we're probably about, we don't want to make any changes. And then as we see, we've got a higher oxidized surface, a more porous surface, a pock surface, then we probably need to add to our shot rate. So these are things that the inspector and the contractor, you can't just start shooting on a chip seal job and forget about it. You can't look at, okay, our design says 0.32 gallons per square yard and 24 pounds per square yard of aggregate, and you just shoot that. The foreman and the inspector need to be out ahead and look at the road and say, hey, at mile marker 2, there's a surface change and it goes from flush to oxidized. We're going to need to up that shot rate or we're not going to get embedment. And those folks need to work together and make those determinations. Spreader checklist is a lot easier. We're just wanting to make sure that our aggregate drop is longitudinally correct, and we can calibrate the computer just the same way as we did with the distributor. The chip spreader folks have pads that they give you. So uniform aggregate application is a must. It's calibrated to ensure consistent discharge across the width. Inspectors need to kind of take a look and make sure that hopper's clean and not free of debris and clogs. If they've been using a aggregate that's got a lot of fines, it can clog up those gates and they won't be dropping what the computer thinks they're dropping. Excuse me. We want to make sure the hopper gates are set correctly. Normally, all the hopper gates across they're designed to open and close at the same rate. Sometimes with a rutted pavement, we may open and close at a different rate over the rut and to get a little more aggregate into that area or a little less aggregate. So that's important. We do want to make sure that we've got correct tire pressure. If we've got too high a tire pressure in that chipper, it's liable to bounce as it's going down the road, and that can affect your application rate. Here we see we're checking the calibration on the chipper. They sprayed over these nice pads of canvas that are provided by the manufacturer. I believe, if I remember right, those are 1 square yard pads. And we pick it up, we grab our fish scale, and we weigh it. And it's pretty simple to know what our application rate is in that area. And you'll see they're going to check another one on the other side of the drop zone and make sure that they're right. And so that's important to do prior to every project. So your haul trucks make a difference as well. And so they need to be compatible with the chip spreader. They need to keep their tires clean. They don't want to be doing sharp turns and making backing up and turning on the fresh mat. You need enough trucks to do the job, obviously. We don't want leaks. Hydraulic leaks will kill your chip seal before you even gets traffic on it. We like that they stagger their wheel path as they back up into the chipper. And this is really important if you've got a rut in that road and those trucks are just going to try and follow in that rut. And they're going down that fresh chip seal. And if they're all in the rut's already got too much asphalt, you're going to have over embedment before you even hit your rollers. So that's really important that we're staggering those trucks and not letting them run in that rut. Chip bar and tailgate latch are required. Some truck air bleed valves go straight down, and if it bleeds a bunch of air at the wrong time, it can actually damage that seal. It can blow those chips right off of that fresh asphalt. So So if you see that happening, we might need to we might need to put some 90-degree angles on those. So again, we want to make sure that our trucks can be that our hitch and our hitch bar on the trucks hook up correctly. Okay, this is one of the most important parts of the chip seal job, and it's one that we don't even think about a lot, and that is the stockpile and loader. Number one, that loader, again, hydraulic leaks are killers. We can't be getting hydraulic fluid or diesel onto our chips. The asphalt won't stick to it. We need to keep that stockpile clean and stable, so we're not pushing mud up into our chips. We need to be free of free draining, so we don't have our chips saturated at the bottom of the pile. And I think one of the biggest things for a chip job, and where contractors make one of the biggest mistakes, is they handle that aggregate too much. And again, a specification of -200 of 0 to 1.5 is best practice, and really 0 to 1 is best practice. And that's great if you check that at the quarry and you get 0 or 1% -200 at the quarry. But if they put that in a truck and they ship it 100 miles, and then the contractor, they dump it on the ground, and the contractor comes in with their loader and builds a mountain of chip seal aggregate and is driving that loader up that mountain to keep it stockpiled, they're liable to grow fines. And you're going to take a rock that was in spec, and by the time it gets out to the road, it's got more fines than what we want, and there's a chance that emulsion is not going to stick to it because of all those fines. So we want to watch that stockpile. There's some contractors, when they can, they never even push up the rock. They just make truck dumps out there. Other contractors will, if possible, will haul directly from the quarry and not stockpile it. That costs a little more, but that keeps that aggregate clean. So as an inspector, watch how they're handling that rock. And I don't remember where your spec calls for the aggregate to be tested, but to me, it's best to test it right as it goes into the chipper, not as it comes out of the quarry. Rollers, 9-wheel pneumatic rollers are best practice. Minimum 2, 3 is best. We're not compacting with these rollers. We're just orienting the aggregate on the flattest side. We're somewhat embedding the aggregate in the binder, and we're kind of achieving a mechanical lock of aggregate particles. 8-ton is minimum for best practice. If I remember right, your spec will go over it, but it's 12-ton, and that's fine. More than weight, what's important is your tire pressures. You want your tire pressures around 85 PSI, and you want no variance that more than 5 PSI between all those tires, because you want the pressure to be the same as that 9-wheel roller kind of rocks and rolls around the deviations of the roadway. You'll notice that our best practice does not allow a smooth drum roller. The Washington spec does. I think it allows it for limited. Again, best practice says that we want to use the pneumatic roller for the chip seal. Broom checklist. The brooms can make or break you. Number one, they're used for cleaning ahead of the game, but then they're used for removing fresh chips, and so we don't have windshield damage. And so we really want self-propelled. We really want the 4-wheel brooms, those little 3-wheel kick brooms. They're great for small jobs, but because of the 3-wheel, they're not as stable, and that broom core can dive in and actually remove too many chips at sometimes if we're not careful. The main thing with brooming, we'll talk about it a couple times, but do no harm. We just want to be removing the loose chips. We don't want to be pulling chips out of the membrane. Plastic bristles are the best for that. We really don't want a full set of wire bristles. Those will flick that they'll do a better job of cleaning the road, and they can flick those fresh chips out of the membrane. And so full plastic is best. If we can't do that, the combo broom cores are okay, but we really don't want 100% wire brush. Water may be used for dust, and there are times when if we're in a curb and gutter section, we might need a vacuum or a pickup sweeper as well. Check my time here. Okay, hour and a half, we're good. Okay, we're gonna go about 15 minutes and then we'll take another break. I want to talk about application strategy. So we've talked about what the equipment should be like. We've talked about the materials, how the materials affect embedment. Let's talk about the application strategies that we're going to use. And again, we've talked about road preparation and weed removal, fogger longitudinal paint lines, remove any thermoplastic or cold plastic striping. We've pre-sweeped, we've protected our utilities. We've got our temporary markings in place. And one that I need to add to this is we've fog sealed any fresh patches. And so we're ready to go. Traffic is important. It's a little different on a chip seal. I mean, we want to keep traffic off until that emulsion cures sufficiently to hold the aggregate. But once we can safely put traffic on, if we can use a pilot car and we can get the speed of the traffic controlled by the pilot car, we want to get that rolling 15-mile-an-hour traffic on that chip as soon as we can. Now, if we're not controlling with a pilot car, or we've got a 4-lane section, we don't want traffic just to hit it at whatever speed they want and do whatever they want to it. But again, controlled traffic at the beginning really helps that embedment, adds another set of rollers to it, and helps the quality of the chip seal. Other folks, they'll close that road completely and they'll chip full width and then take that 3 miles and open it and go the next 3, and that's fine too. Multi-lane roads, again, because we can't control the speed of the traffic. We want to keep that chipped lane closed completely as long as we can until it's fully cured and we've swept it. Equipment placement. If you haven't been on a chip seal job, the first thing is the distributor. In this slide, this person that I shall we say borrowed this slide from, instead of distributor, they call it a spreader truck. Then followed by the distributor is the chip spreader, and that is about 150 feet behind is the sweet spot. 150 feet or about a minute behind is where we want to be. That's one of the most important best practices of doing a chip seal. And again, on this job where we're rutting, it's even more important. And what happens is that distributor gets going and gets way out ahead and isn't communicating with the chipper, and pretty soon that distributor's out 5, 6, 8 minutes out ahead of the chip spreader, and your emulsion is starting to break before the spreader even gets to thinking about dropping chips on it. It gives that emulsion time to flow downhill, whatever downhill is. It gives it time to flow and get more in the bottom of the ruts. And so we really need to keep that chip spreader right up behind that distributor. And then we have our chip trucks following behind, staggered, so they're not all in that wheel path. We might have some crews use a patch crew, some don't, just making sure that, we don't want any areas either with humps of rock, or even worse than that is areas where we have free emulsion without any rock over it, because if our rollers get into that, they're gonna just start picking up, and you're gonna have to stop the job, clean the rollers, and might have to redo some of it. So we have our rollers coming in there, and then our brooms come in after the rollers. And so that's kind of how it works out in the field. So again, we want to keep that distributor and aggregate spreader together as much as possible. Now there are times, that chip spreader has to pick up a truck, and so they will get behind the distributor a little bit, but they can catch up if they do a good job of switching trucks. They can catch back up. So we want to keep that generally within a minute, or generally within 150 feet, whichever work is easier for you as an inspector to figure. So look at this animation. You can't beat it, huh? You didn't know what you were going to get when you got up this morning. So we wanted something like that. We don't want that distributor going way ahead and stopping, and then the chipper have to catch back up, and then the distributor goes way ahead. We really want that as a smooth operation as much as possible. So air and ambient temperatures, best practices are above 55 degrees, and we want it to maintain over 40 degrees overnight. I will tell you, 55 degrees scares me, unless it's going to be 55 early in the morning and get to 80 in the afternoon. If it's 55 and it's only going to get to 60, I personally would not want a chip seal. There are some parts of the country that's the only temperatures you get. I understand that. I really like it. If you've ever looked in the Bearcat chip spreader or distributor manual, I think it's in both. There's a line in there that says, if you're wearing a coat, it's too cold to chip seal. And I think that's a pretty good line to use. So the air and ambient temperature are important. The other thing to think about is temperature in the spring and early summer is different than, so 60 degrees in the spring is different than 60 degrees and coming into the fall. And if you think about it, in the fall, your temperatures are getting less and less normally, and there's less room for air in the fall. If you shoot on a 60-degree day and you don't get, and the next day is 55 and the next day is 40, you're liable to have a failure. In the springtime, when temperatures are generally increasing, you've got 60 degrees in the spring, maybe you'll get away with if it's sunny and it is going to warm up. So really think about that. We want dry pavement. We obviously we don't want rain forecast for 24 hours, but you just have to do what you got to do sometimes. But if there is a torrential rain forecast for within 24 hours, I would think before chip sealing that day. We want to heat our emulsion to manufacturer requirements. Generally, that's somewhere between 145 and 185 degrees. We never want to heat more than 185. We don't want to take the chance that our thermometer is off or the operator kind of falls asleep and heats that material up over 212, where they can boil water out of it, and then you've got goo. Your viscosity's gone. You may not even be able to spray it. So don't ever heat above 185. And then from there, you want to look at your manufacturer's requirements. Again, aggregates damp but not wet. It's very good if as a best practice is put a tar paper shot at the beginning and end of the shot, so that allows that distributor kind of get up to speed, gives them a place to start and stop without making a puddle of emulsion. And then chip spreader width set to leave a narrow strip of uncoated emulsion. I think actually your spec is an 8-inch, if I remember right, and that's the biggest I've ever seen, the widest uncoated strip or without the aggregate, but that's fine. That's your spec. Again, chip spreader stays within 150 feet of the distributor. We hit that all the time. I know you'll be sick of hearing that by the time we're done, but that's also the most violated best practice that you'll see out there. Adjust the speed so that the spreader's not bouncing. It's really good to do a 1,000-foot test strip. And I think, again, with this project, with us doing ruts, we want to make sure that everything's working, that our embedment is correct. So I would, as contractor, as inspector, I would ask for, let's do 1,000 foot, and let's make sure that we've got embedment. Let's make sure that the chipper's working correctly, that the rollers are rolling correctly, and that we're getting the quality that we want. Really important, aggregate application. Next to having the distributor way out in front of the chipper, the next problem most folks have with a chip seal is we put way too much stone down. We're so scared of having a bleeding chip seal that we over apply stone, thinking that's going to solve the problem. But too much aggregate is just as bad, or actually worse, is not enough. What happens is we want single stone embedded, and if we get multiple stones stacked on top of each other, when that top stone gets rolled in, it's going to not only knock itself out, it's going to knock out all the stones around it, and you're going to have aggregate, that you're going to have areas without any aggregate, and they're going to cause bleeding. And so what we're looking for is a salt and pepper kind of look. And I like this picture because if you look to the lower right, that's not enough aggregate, right? That's a little too much pepper showing. And then if we work our way diagonally up to the top, we see in there we see that we can see emulsion or asphalt in between the aggregate particles. And that's really what we want to look at when that material's been chipped and then after it's rolled. If we can't see any black in between the aggregate, we've got too much chip on there. And that's going to cause that we're going to over embed some of those chips. We're going to have excess chips to broom off. If we have to work hard to broom off those chips, we're liable to dislodge chips that shouldn't be dislodged. And it just makes life worse for us. So, again, we need to think that we are placing a membrane of asphalt emulsion, and we want a single layer of chip dropped on that. Not 3 layers of chip, not 4 layers of chip, a single layer of chip with a salt and pepper appearance. We need to have enough rollers available to make 3 passes while keeping up with the chip spreader. This is one of the most controversial sections in this best practice. The rollers not exceeding 3 miles per hour. I understand that's low. Your spec has 8 miles per hour. The main thing is the rollers can't do harm. And so if they're going too fast, whether that's 3.5 miles per hour or whether that's 9 miles an hour, but if you see rooster tails of material being dislodged, then you know that you're rolling too fast. And so we want to limit our turning and stopping on the fresh seal. We need to keep our tires clean. You can see that photo there of that roller there. Those tires are not clean. That could be causing some pickup issues, and they could be messing up on what could be a good chip seal. Rollers, again, at least 3 passes, and a pass is up and back. There are 2 roller patterns and 3 roller patterns. Pretty easy. I will say that if you think about it, a lot of contractors or agencies that do chip seal think that their speed is controlled by the distributor. How fast can I spray the emulsion on the road and keep moving down the road? But your speed is actually controlled by your rollers, because for best practices, if you think about it, you want to roll within 2 minutes of application. You want that first roller to hit within 2 minutes of aggregate application. You need to go back and forth 3 times at a speed somewhere around 5 miles per hour, at a speed that's going to cause no harm. And then you need to keep up so that the next chip drop, you're back up there within a couple of minutes. And so your rollers are what control the speed of your chip operation. And I think that's very important. And so if you're an inspector and you're seeing that my rollers are way back there, I can't even see them from the chipper, you've got an issue. And the contractor needs to adjust their application speed to allow those rollers to be closer to the unit. Brooming should start when emulsion's cured, usually between 1 and 2 hours after rolling with a cationic system. Again, light brooming only. Heavy brooming removes excess chips. Excess chips remove other chips, and your embedment's lost. And so the less chips you put down, the less hard you've got to broom. Keep that broom, that centerline joint back if you're doing that. And then you can open to controlled rolling traffic as soon as safely possible. So final thoughts on embedment. So embedment of the stone is key. Everything you do should be aimed at achieving proper embedment and minimum stone loss. And so we've got our depth of our membrane as the chips are being applied. And then just after the chips have dropped in, we've got a certain embedment. And then we're going to roll those 3 times with the roller, and that's going to orient those chips to normally their longest side. It's going to get that embedment even more. And then that last photo there is after some traffic. And what is some traffic? Well, that depends on the amount of traffic. But after a few days of traffic, we want to make sure that we've got no more than 70% embedment. So we are going to take a break.
Rex, did we lose you?
No, there you got me.
Okay, there you go.
Yeah, let's take let's take a 15-minute break on this one. So 5 after the hour, we'll come back. How about that? All right, we'll go in 1 minute. Before we get going, can someone from the DOT confirm? I believe we do have fog seal as a final application on this section, but if, can someone confirm that?
That's correct.
Yeah, okay, thank you. Didn't want to talk about it if we didn't have to, but good. All right, we're in the home stretch. Let's see if we can get this thing done and get you guys to lunch. All right, so we're going to talk a little bit about fog seal. Fog sealing chips is starting to be common practice almost all the way across the country. I think one of the first ones was our friends here, Joel and those folks from Minnesota DOT really started that quite a while ago, and that's kind of picked up steam across the country. Number one, it helps with locking in those chips. There's anecdotal evidence that it reduces some of the snowplow damage. I mean, obviously, if they're going to drop it down hard and really go, it's little fog seal is not going to help, but it does help that, and the citizens like it. They think they got a new road rather than a chip seal road. So fog seal gives us a lot of good bang for the buck for not a lot of money, and so I like that. So we talk a little bit about fog seal on dense graded and chip seals. I know this is on a chip seal, but the thing is, you're only chip sealing the lanes, and so we kind of got a little hybrid coming along, or you're only chip sealing the ruts, and so we kind of got a hybrid going here. But on a dense graded, obviously, it does protect the asphalt from oxidation and moisture, reduces raveling of dry mixes, and fills fine cracks. And so folks that are doing a fog seal on a dense grade as a preservation treatment are getting a lot of use out of it. Chip seal, obviously, again, we're protecting the chip seal asphalt from oxidation and moisture. We're locking in chips, reducing snowplow damage. Dark surface helps with snow and ice melt and highlights the pavement markings. Oh, that too many times. Emulsion fog seals are kind of all across the board. There's folks using CSS1H, SS1H. Some people will use CQS, which is a quick set slurry emulsion. They feel that gives them better return to traffic. Some states are using the non-tracking tackless track. Some folks are fogging with a polymer modified rejuvenated emulsion. So really the emulsion that you choose is kind of up to what's available and what you're normally using. We like to, best practices is that the material is pre-diluted from the emulsion plant. We don't let just Joe throw a hose up over the top of the distributor and trying to get it diluted and then drive it around the block twice to mix it up. We really want that dilution to happen at the emulsion plant. Pre-dilute, normally folks like to look at about 27 to 35% residual asphalt. That CSS or whatever most folks, or I guess the emulsion, I don't know why I put just CSS1H, but we want to heat that to about 150 prior to application. And again, never go over 185. If you're going to use a blotter aggregate, a fine aggregate works fine. Use as needed for pedestrian traffic or if you've got over applied emulsion or anything like that. Emulsion application rate typically ranges from 0.1 to 0.15 gallon per square yard. I always like to start a test strip application toward the bottom of that to make sure we're not flooding the surface. I think that's going to be interesting here when you have part of your road is a new chip seal and part of the road is whatever was there before, and getting that application correct across that width so you don't have too much in some places and not enough in others. And so I think that's going to take some time to probably get those nailed down. And again, just like a chip seal, the inspector and the contractor need to work together and talk about what the road's doing up ahead, and you can't just grab one application rate and stick with it, because you need to adjust that as needed to completely coat the surface. Best practices of the distributor are the same really for fog seal as they are for chip seal. We want that 12-inch overlap. Most of the times we want a triple overlap. There are some contractors I've seen who have experimented and had pretty good luck with every other spray nozzle and fog in that way. And I mean, there's reasons to look at that if it gives you a better application, but generally we're looking for the same setup as we would for a chip seal. Again, we want to make sure that we've got the correct distributor nozzles. They are different than chip seal nozzles because we're lighter application rate, viscosity is different, that sort of thing. Best practices, obviously, we want to sweep the roadway, especially on the portion that isn't freshly chipped, because we should have swept well with a chip seal. We've got to cover our manholes, valley gutters, except everywhere. And we want to start with that 500-foot test strip to check our application rate, make sure that we're getting all the aggregate coated without ponding, or we want to make sure we're not rolling, letting emulsion run off into the ditch or into the shoulder. And we just want to make sure everything's looking good, that our nozzles are all working and that things are good. One thing that some folks like to do is they'll cut that spray application in half and spray both directions, and they feel that gives them a better coating, especially on the downside aggregate. So we get better coating all the way across the road, and that's that's not a best practice. That's something that works for some applications and not others. But it's obvious. It's certainly, as an inspector, if a contractor wants to try that, there's no reason not to try that. Obviously, we want to allow that asphalt emulsion to cure before we allow traffic. Minimum cure time is going to be 30 minutes, but obviously that's environmental changes and conditions and application rate and all sorts of stuff plays into that. Troubleshooting, if we've got excessive splattering, we could have bar height is probably too high or too low. Spray pressure is too high. If we're getting streaking, we might have our emulsion may be too cool. It's not pumping correctly. We might have nozzle angles off. Bar height might be off. We might have plugged nozzles. Pump pressure's too low. Clog streams. There's things to look at. Those are the things to look at as an inspector or a contractor if we're getting streaks in our fog seal. And then, of course, obviously, we're getting bleeding or flushing. That application rate's too high for the conditions. And we need to remember that those conditions may have changed in the last 500 foot to 1,000 foot of road. So that's very important. So let's stop. I just want to make sure that there's no questions on the best practices that we've talked about, both for chip seal and fog seal. I don't know if our contractor made it. Hopefully he's on board with all this, or if you've got any questions or comments, or you don't do things the way we've talked about, love to discuss it. So anybody got anything?
I don't think our contractor was able to join.
Oh, okay. All right. Well, then you get to tell him what to do, huh?
Yep.
Never, ever miss a training class if you're a contractor. You gotta, that's add form. Okay. Let's kind of run through your specs really quick. Oh boy, these did not come out very well. Hopefully they're better on your end than they are on my end. We're not going to go deep into these. Your specs are very close to best practices. We get down into the equipment, and you have the same requirements of the distributor that we talked about under equipment. Your rollers for seal coat should be self-propelled pneumatic. You do allow a smooth drum, a steel drum roller. I'm not a fan of those. I especially wouldn't do it here where you allow it where you've got ruts, because that smooth drum is gonna bridge over your ruts, and you're not going to get any compaction in the bottom of the rut. And so that's why it's really important that we're using pneumatic 9-wheel rollers on this project. The aggregate spreading equipment, that's good. You need it to be self-propelled. We're not allowing them to use a truck bed spreader, and that's good. And they've got positive width control. So your spec here is on the equipment end is really good. Pretty light on the broom spec, but that's really all you need here. As we go down into 502.32B, which is where we get into seal coats, not new construction. For the prep, we're talking about sweeping with a power broom till it's free of dirt. Hand brooms might be needed. Obviously, if there's any dirt or aggregate or carcasses or whatever on the road, we're gonna have a failure there. The chip seal's not going to stick to the road. So cleaning the road is vitally important, and that's one thing that a lot of times we have failure because we did not clean the surface correctly. We talk about the fog seal. We need to clean prior between dust and all that, and that's very important there. We are calling out crack sealing, and I believe you are crack sealing this project, and that's good. Again, we want to make sure. I think the way the project's set up, that the sealing probably won't be done 30 days out. That's okay. That's not best practice, but we do want to make sure that they're keeping their overbands. We don't want globs of crack seal up on top. You're going to feel it. We want to keep their overbands as thin as possible, but make sure they're following other best practices for crack sealing. So we talk about our application rates, and can someone tell me? I did some digging. I couldn't find. Does the DOT do the mixed design or the final application rate, or does that come from the contractor? We probably ought to figure that one out.
Yeah, I'm not 100% sure, but we definitely should probably figure that out.
Yeah. So looking through this spec, other than that, it's pretty normal. I like the fact that you can charge them for joints that are outside where you want them and they're rough. I kind of like that. And look, I'm an old contractor, but we got to do it right. And so if you need a stick to keep it done right, that's really good. You don't really talk about the distance between the distributor and the chipper. However, you do talk there at that last line on there, the area covered by any one spread of emulsive asphalt should be no more than can be immediately covered with aggregate before the emulsion begins to break. And so you can use that there if they're letting that distributor get way out ahead of the chipper. And so you can use that line, because like I said, I don't remember seeing where you had a distance or a time limit in your spec. So, and I might have missed it, but so we can talk about that. We talk about even application. We spread in one operation. We talk about that an 8-inch strip of asphalt is left exposed to form a joint, and that's fine. That's best practice. Like I said, 8 inches is a little higher than I've seen in a lot of places, but there's nothing wrong with that. We might have to take a couple-minute break. I've got a issue with my computer that give me about 2 minutes and I will be back. My charger is not working. I thought it was. So let me go get another one and we'll get this thing plugged in. I apologize for not checking that. Hold on here. Talk amongst yourselves.
Sure, thank you.
Yeah, if anyone's got any questions or some things that we're not covering here that you're interested about, just let us know.
Well, this is Joel from Minnesota. I was just kind of curious, have you guys done the wheel track chip seal before? And how has it performed?
We have in a couple different locations. For the most part, it's actually worked really well. There's been a couple locations where we've had a little bit of stripping along the edges of the wheel pass, but nothing like, really substantial. But there's one section down by Wallula over on east, and it's been doing really well lately. So it's only a couple years old, but yeah, we've had some pretty good success with them actually. So
Okay. And then have you ever like chip sealed the wheel tracks, but then come back and chip seal the road? Full width.
we have not done that yet, but that's been our intent. If we had
Okay,
funding,
yeah.
yeah,
If
we
the
would
budget
definitely
was there, you'd do it, right?
exactly.
Yeah, because I'm sure that'll help fill that rut a little bit.
Yeah, it's just kind of seen as like an interim, hold it together for now type of thing. And yeah, if we could
Yeah,
go back,
more of a
that's
Band-Aid. Yeah.
Yeah.
Yeah. Yeah, it's just curious that, it's a little unusual, I haven't seen that before, so.
we thought the
Looks
same
like Rex
thing.
is back.
We thought the same thing, but it's worked pretty decent. So
Okay.
Perhaps it looks like we're seeing your screen, but we're not hearing you.
How about now?
Yep, there you go. Thanks.
Okay, it was muted where it shouldn't have been muted. I apologize, folks, for that. I should have been better prepared, but it happens. Let's see, go back to, you do require a choke stone. I think that's as necessary, just to make sure we're not getting any bleed. And so again, your specifications are pretty good. We didn't see anything that needed to be changed, and that doesn't fall under best practices. There's a little differences here and there, but I think they're fine, and there's nothing we really need to talk about. Your weather limitations are 60 and rising, not less than 70 degrees when falling, and I do like that. And the wind should be less than 15 miles per hour. Surface temp not more than 140 degrees, and then you've got your May to August construction time. So yeah, it's all very good specification, and I think that's good stuff. So all right, we are going right perfect on time. So again, what is this study all about, and what are we doing out there? It's a pooled fund, and it allows folks to pool their funds, and so they get subject matter expertise, and we've got in these meetings that we have folks learning different states, learning from other states, and then we're going to be able to take all this data and get it back out to the states, and you're going to be able to learn what Minnesota learned on their Cape Seal, and you're going to be able to learn what North Carolina learned on rejuvenators, and there's other good stuff coming, some recycling projects. And so this is all about helping states get better pavement preservation projects is all what we're trying to do. And so this all fits into the PG1 test sites, PG2, the Minnesota test facility, and then the national partnership through all these folks. So we've talked about all that. So the test cell construction. Now this gets a little confusing for folks, and I do wish, I was kind of joking a little bit, I do wish the contractor was here, because we want the contractor to understand that yes, this is a test project, and yes, there is a test cell that they're doing, but in no way do we expect to slow down the contractor and keep them from getting their work done because we're observing this test strip. We'll either have probably both. I think that we've got some FP2 people. Those are contractors or suppliers that are up in the Pacific Northwest that can come down and be a part of the day that we do the test cell construction. Hopefully I'll be there from NCPP, as long as it's not the first week of August, because I'm booked that week. But after that, I should be good. We'll deal with that. It might be Todd, it might be Mark, we don't know, but we'll have someone there. And but again, this test cell we're just there to observe, and we'll talk about all the things we're going to observe here in a minute. We would like from both the agency and the contractor that we get a 14-day notice of anticipated construction date. And I know in this business that is wildly inaccurate, but if we get a notification that, hey, in about 14 days, we're going to start the chip seal on this project, then we can be in close communication, just like we've been doing with Alaska, trying to figure out their schedule. And then once we get to about 5 days out, then we need to start making our travel plans. And so we'll check with you and say, hey, are we still, does it look like next Wednesday is going to be the day? And you'll probably have to check with the field team, and we'll figure that out. And then we kind of want a 48-hour go, no go. And we understand that things happen, but 48 hours out is when I'll have to leave, the next day. And we just want to go, have a discussion with you. What's the chances of it going to happen within a couple days of today? And so, if I fly out and I hit the ground and all of a sudden the chipper breaks down and it's down for a day, or it rains, we'll wait for a day or two to make sure that the test cell gets construction. But if it's, like it was in Alaska, they never knew when they were going to go because it was all weather dependent. And so if we either can't come out because of problems, or we come out and problems happen and we don't see the test cell happen, it is what it is. But we really want to have someone from our group on site the day we do that test cell construction. And the main thing is there to be there to help you all gather the data that we need. We're hoping that we get this done during weekday daytime hours, but we understand it could be a Saturday or Sunday. Do we have your test cell location? I mean, I know we know the project, but do you know where you want your study section of roughly about 3,000 feet?
Yeah, unless that's changed. We have that.
Okay.
His question, has it changed?
I don't believe no.
Okay.
Yeah, it shouldn't have. I think we were like going at the ends, I believe, if I remember correctly. But
Check. I was thinking it was right in the middle, but let me check.
okay, maybe it was.
And again, why we're checking that actual 500-foot section can move a little bit as long as everybody knows where it is. And why would it move? We'd really like to not have a distributor change right in the middle of the test cell, even though in Minnesota we got 2 distributor changes on both of them. But we talked to the contractor, can you make it through here? Yeah, no problem. Yeah, they didn't. So it happens, and it's not a disaster, but
It's all in the timing, Rex.
it's all in the timing. That's right. But you know, if they're going along and we're getting close to the test strip and there's like a slight problem with the machine, and we need to move the test strip 1,000 foot down the road or whatever, well, that's okay. That's not a disaster whatsoever. But the reason we pick a place now is so schedule wise, we know when to get there, we know what to look for, and all that. And so what we really need from the contractor is we just need in the morning, or so we don't slow them down. We'll be at the stockpile, and there's things that we need to help you fill out that's in the paperwork that we need to look at the equipment and take a look at it and make sure it meets best practices, get some numbers off of it, get some information on all the equipment. We'd like to see their calibration information. If they're the ones that did the mix design, we need to see that. And then we may have some questions for their supervisor or their crew, but other than that, we don't bother the contractor whatsoever. We don't tell them no, stop, no, go, stop, go. No, we don't do any of that. We just observe. The only thing we may do, like I said, is move the exact 500-foot test cell a little bit if there was a reason to do so. And that's one of the reasons we like the contractor at this thing, so they don't sit there and think we want them to be on our side when we go in to do it. So there's some responsibilities at the test cell. We would like one agency person on site designated to assist us in record keeping process. Doesn't matter who it is. Could be one of you that's been through the training. It could be it could be an inspector. It could be whatever. But we need one person kind of in charge of that. That's doing that record keeping. We want we'll provide you with the data forms. You probably have them already, but if not, Todd will get those to you. We want the agency to make sure their specifications and best practices are met through your inspection process and your specification process, and that's why we do this training. You're responsible for all field data retention and storage, but we keep it too, so that's no big deal. And then we ask that all the data be shared with the entire pool study team, MnDOT, NCPP, NCAT, in a common protocol, which is all we've all done. As long as you're using the forms that we provide, we're in good shape there. Our job with NCPP is again, we'll go through the equipment. We'll kind of take a look at the material in the stockpile, and we're not doing this to catch the contractor or prove anything's right or wrong. We're just doing it to gather information. And if we see that there's something in the best practice, that a best practice isn't being followed, and yet we still get a good project, well, then that gives us something to study. Or if we see that the best practice isn't followed and we have a failure and we can point to that allows us to change our training or maybe change how we write our best practices. So that's the only reason we're here, is to learn, observe. If there's questions out there, if the contractor wants to understand the best practices or wants us to talk to the crew about anything, we're happy to do that. But if not, we won't even bother the crew other than to get access to the information that we need. And then we're here to assist you all with the completion of your data forms, We also hope that our FP2 partners who are in the area can go out a few times over the next few years and kind of take a view of the project and make sure how it's performing. We'll do an after action review of how the test cell went and what happened and what went right, what went wrong, and that goes into the data. So that's what NCPP does. So if I'm able to be out there, that's what I'll be working on that day. Again, the contractor's role is provide access to the equipment, the employees, and the materials, perform the work that meets the spec, meets project spec, industry best practices, and we might need them again to assist in gathering data if it's not clear what aggregate supply, whatever it is. We just need them to assist. Did you all have a special provision about this test project in the plans, or does the contractor even know about it?
There's no special provision. The contractor's been made aware, and a little bit was kind of, well, what exactly is that going to entail? And I gave him some of the basics, and obviously, expressed to him that this training would clarify any questions he may have, and that's when he expressed that they're pretty busy and will do their best to attend, and they weren't able to.
I get it. Okay. All right. If we have any industry volunteers come out, they'll assist NCPP. They take photos, videos, and then again, hopefully they'll be able to review that project in post years after we're done. Again, so I think that's the right project. It was the SR14 section. I've never been in that part of Washington State, so that'll be good. So we're performing pavement repair in high distress areas, basically remove and replace, but you're only doing surface removal. Was this the one that's like 60 years old? It's been chip seal after chip seal. Is this that section of pavement? That's amazing. Got some shoulder repair. We're crack sealing full width. We're doing a 3-foot nominal width surface treatment using CRS 2P in each wheel path. Okay. Does anybody know? My guess is the contractor is going to set up and set their distributor and their chipper up to pull these 2 wheel paths all in one pass. Hopefully the ruts are consistent enough they can do that. That's going to be something as an inspector we want to look at. If those ruts are roaming around in the lane, they're getting further apart and closer together, that might make things really interesting. So we'll have to see how that goes. And then we're going to do a fog seal. Oh, okay, so we're not fogging the entire roadway width. We're only fogging over the chip. Okay, I missed that before. All right, that's interesting. So there's no striping, no nothing on this. Okay, all right. So the different forms that you...
Bare bones thing.
Yep, I get it. So here's the chip seal pre-construction form that we can help you all fill out. Most of this is going to come off your data, but we already know the type of binder is asphalt emulsion. We need to find out if there's a design method. That's something that you all probably want to check on. Any comments on that? Our application rates from the design, any material test results, we'd like those sent in, gradations, emulsion testing, whatever. The general condition, there's the LTPP severity, which goes above my pay grade, but what are the primary and secondary distresses? We can help with all that. If there's any questions of what we're looking for, we've got folks from MnDOT that can help with that. But this is the type of pre-construction information that we're looking for. And then we have well, this was the scrub seal, but it's all about the same as we talk about what preparation was done, and so while we've swept it, we know that we've got some patching we're doing, we've got some edge shoulder repair. Any comments on that? Did we have to do anything to the pavement markings? Well, probably not on this one. So that's good. Pavement markings aren't covered. What's the moisture on the surface during placement? Those are things that all be there to help us determine. What's our air temperature as we're placing the test cell? What's our surface temp? What's our relative humidity, cloud cover, all that. Those are just little things that we're looking for to understand what everything about the conditions when we pulled that 500-foot cell. We'll check on how many distributors they're using. Do we have a calibration? Do we know when it was done? Are there any documentation, whatever we can put in there? The manufacturer, the nozzles, the angle, all that good stuff we've got for all the distributors. Again, that's what myself and any NCP or FP2 volunteers will be working on. Come on, there we go. We'll talk about the rollers. We'll check the rollers. We'll get the make and model, and hopefully we can get the weight. Make any comments on the rollers. Same with the brooms. Record information on the aggregate source, the aggregate type. Very simple. There's really nothing. There's not a lot here that's not normally taken by an inspector on the job. Here we want to know how long did it take them from once the asphalt emulsion was sprayed to how long did it take us to drop the aggregate in the test cell? How long did it take them to hit that first roller pass? How many times did each roller make the pass? We kind of got all excited here. We've got lots of application rate checks here, which is really hard on a 500-foot section, but we'll try and figure out what that rate was from the computer at the time they were going by. How long did it take to open to traffic? How long did it take to broom? All these things are what we're there to help you get. When did we fog seal? We'll have to get that from you. We won't be there for the fog seal. How long did it take to open to rolling traffic? What was the application rate? So very simple stuff. Nothing major. Again, we're going there on a 500-foot pass, but really we can take a lot of this data from the day that we're working. So it's pretty simple. There's a material test form that we put out. You can probably turn this in on your normal aggregate testing sheet and just give it what's your DOT, but we have that test form there. And that's about it. What questions or comments do you have on the test cell and on what we're looking for?
I have a question for the WASTOP guys. Who's our main point of contact for this construction?
Matt Wilhelm will be your main point of contact. He'll be the chief inspector for the job.
I had written that down, but I wanted to double check that. Okay. And then Matt, if you can email or drop in the chat, whatever your cell phone number, and then Rex and I'll get you our contact information so we can make sure we can get each other.
Yeah, and I only have, I guess, as we get closer, within the project office here and with our materials folks, we'll coordinate who from our staff will be record keeping, or if it'll be someone from the materials office, either region or headquarters. And so we'll coordinate that amongst ourselves. And then other than that, yeah, I think most of the information was provided here in this training, so appreciate it.
Very good.
And Todd you can send them this training if you want.
Yeah. Oh, thank you. Got it. Yeah, Rex, if you can either drop these slides in the SharePoint or get them to me, we'll get it posted on the PG3 website, and then I'll send everyone an email when it's up.
Okay, very good. Very good. Well, I think I bought you guys some time. I thought I was going to be over and I'm not. So look at that. Anything else you guys need to discuss or questions?
Yeah, Rex, this is Joel. All I'd say is awesome job again. I mean, you do such a nice job just walking through stuff, and yeah, you do a very nice job. Thank you.
Thank you. I appreciate that.
Yeah, that was very informative. Thank you.
Yeah, it was a great presentation. Thank you so much.
Okay. All right. Well, y'all enjoy. I look forward to working with you, and I'll get this to you, Todd, so you can get it out to everybody, and we'll go from there. So have a great rest of your day. Thank you. Bye.
So,
Thank you.